Hey there guys, welcome to my channel. Today we're going to be solving a nice system of equations with 7 variables and 3 equations. And we're supposed to solve for A, B, C, D, E, F, G if all of them are positive integers. So notice that all of them are positive integers. And actually we're not supposed to solve for all the values. We just need to find out how many solutions we have. So let's go ahead and start with the second equation. So we have CDE equals 31. Now, the interesting thing about the second equation is that 31 is a prime number, right? So since 31 is a prime number and CDE are all positive integers, we have only 3 cases. So from the second equation, I can go ahead and say that either C equals 1 and D equals 1 and E equals 31, or C equals 1 and D equals 31 and E equals 1, or C equals 31 and both D and E equal 1. Cool. Next, let's go ahead and take a look at the first equation. So the first equation is ABC equals 30. Since A, B, C are all positive integers, that means that C should be a factor of 30. That means that C cannot be 31, right? So the third case is not a valid case. If you look at the third equation, we have E times F times G equals 32, which means that E is a factor of 32, which means that E cannot be 31. And that means that our first case is not valid either. And that also means that the only valid case is the second case. Cool. So E equals 1, C equals 1, and D equals 31. Let's go ahead and replace C and E in the first and the third equation. So since C and E are both equal to 1, we can say that we have AB equals 30, and we have F times G equals 32. Now, since we want to find out how many solutions that we have, let's go ahead and think about how many pairs of solutions that we can get from the first equation and how many pairs of solutions that we can get from the second equation. So in order to do that, we need to find out how many factors 30 has and how many factors 32 has. So let's say that we have a number like 20, and we can factor 20 into 2 squared times 5 to the power 1. So whenever we have a number, an integer, factored into primes, we can find out how many factors that number has. How can we do that? Well, we can go ahead and take the power, that is 2 over here, and then add 1 to that, take the next power, and add 1 to that as well, and then multiply these numbers together. So we get 3 times 2, that is going to be 6. So that means that 20 has 6 factors. For another example, let's say we want to talk about, 54. 54 can be written as 2 times 3 cubed. So if we take the power, that is 1 over here, and if we add 1 to that, we're going to have 2. If we take the other power, that is 3. And if we add 1 to that, we're going to have 3 plus 1, that is 4. 4 times 2 is 8. So we have 8 factors for 54. So let's go ahead and use this method to find out how many factors 30 and 32 has. So 30 can be factored into 2 times 3 times 5. So all of the powers are equal to 1. So we can take each of these powers and add 1 to them. So we have that, right? And if you multiply all of these, we're going to have 2 times 2 times 2, that is 8. So we have 8 factors for 30. That means that we have 8 different pairs of solutions for A and B. Make sense? Cool. Let's go ahead and factor out 32. That is equal to 2 to the power of 5. And that means that we need to take 5 and add 1 to that. And that is going to be 6, which means that we have 6 factors for 32. And that means that we have 6 pairs of solutions for F and G. Now, since we want to find out how many solutions we have in total, we need to multiply 6 by 8. So we have in total 48 solutions for A, B, C, D, E, F, and G. And this brings us to the end of this video. Thank you for watching this video. Please consider subscribing for more contents like this and hit the like button if you enjoyed watching this. Hopefully I will see you later. Goodbye for now.